First, the bad news. SAP Business AI won't help you generate cubist versions of your family's holiday photos. But it will help you understand which supplier is best to help you roll out your plant-based packaging in Southeast Asia, or identify the training your junior project manager needs to rise up the ranks, and automate repetitive tasks while you focus on big innovations, so you can be ready for the next opportunity. Revolutionary technology, real-world results. That's SAP Business AI.
We are Bragg, makers of the apple cider vinegar with the big yellow label, now in capsule form, with even more benefits. So you can put it in your pocket, put it in your jeans' tiny pocket, take it with your morning oats for your health, go bull riding with it, go to the moon with it. Pretend it's a magical pill that helps support immunity. It has zinc and vitamin D, so it does. Carry it in your purse. Carry it through airport security. Take that, TSA. It's Bragg apple cider vinegar, now in capsule form. Bragg, it's not weird if it works.
This is SpaceTime, Series 26, Episode 127, for broadcast on the 20th of October 2023. Coming up on SpaceTime, the plot thickens in the hunt for Planet 9, new clues on planetary formation, and fresh insights into the atmosphere and star of an exoplanet. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A pair of theoretical physicists are reporting that the same observations inspiring the hunt for a ninth planet at the outer edge of our solar system might instead be evidence of a modified law of gravity originally developed to understand the rotation of galaxies. Reporting in the Astronomical Journal, researchers Harsh Mathur from Case Western Reserve University and Catherine Brown from Hamilton College made the assertion after studying the effect the Milky Way galaxy would have on objects in the outer solar system. That's if the laws of gravity were governed by a theory known as modified Newtonian dynamics, or MOND. MOND proposes that Sir Isaac Newton's famous laws of gravity are valid only up to a point. That is, when the gravitational acceleration predicted by Newton's law becomes small enough, MOND allows for a different gravitational behaviour to take over. The observational success of MOND on galactic scales is why more and more scientists are considering it an alternative to dark matter. The term physicists use to describe that mysterious hypothesized form of matter which is invisible but has gravitational effects on surrounding regular matter. It's thought to be what stops galaxies flinging apart as they rotate and provides an added degree of magnification during gravitational lensing events. Mathur says MOND's really good at explaining gravitational observations, but it wasn't expected to have any noticeable effects on the outer solar system. Mathur and Brown have studied MOND's effects on galactic dynamics before, but they became interested in MOND's more local effects after astronomers announced in 2016 that a handful of objects in the outer solar system showed orbital anomalies that could be explained by a ninth planet. The hunt for that missing ninth planet's been going on ever since, but to no avail, at least not yet. Meanwhile, Brown realised that MOND's predictions might be at odds with the observations that had motivated the search for Planet 9. She says they wanted to see whether or not the data that supported the Planet 9 hypothesis would effectively rule out MOND. Instead, they found that MOND predicted precisely the clustering that astronomers had observed. Mathur and Brown argue that over millions of years, the orbits of some of the objects in the outer solar system would be dragged into alignment with the galaxy's own gravitational field. Mathur says that when they plotted the orbits of the objects from the Planet 9 dataset against the galaxy's own gravitational field, the alignment was striking. However, the authors caution the current dataset is small and that any number of other possibilities might prove to be correct. For example, it's been argued that the orbital peculiarities are all the result of observational bias. Brown says regardless of the outcome, the new work highlights the potential of the outer solar system to serve as a laboratory for testing gravity and studying some fundamental problems in physics. This is SpaceTime. Still to come, astronomers have discovered the youngest hot Jupiter ever seen, and new insights into the atmosphere and star of an exoplanet. All that and more still to come on SpaceTime. Okay, let's take a short break from our show for a word from our sponsor, NordVPN. And today we're bringing you something that's going to elevate your internet experience to the next level. Imagine exploring the vast universe of online content securely and privately, just like traversing through the mysteries of space, but with an invisibility cloak to protect you. Sounds intriguing? Well, our friends at NordVPN can make that a reality. But why choose NordVPN? Well, picture this. You're navigating through the cosmos of digital content, accessing streaming platforms and communicating with people right across the globe. But the internet is filled with entities, not all of them wishing you well. And that's where NordVPN comes in, encrypting your data, masking your location, and shielding your personal information from prying eyes and malevolent forces. And because you're part of our SpaceTime family, NordVPN's offering you an astronomical deal light years ahead of the others. Now get yourself a 2-year subscription and receive an additional 4 months absolutely free. That's a universal journey of online protection lasting a full 28 months. And there's more to this celestial offer. With NordVPN, you're not just getting a VPN, you're also enjoying the freedom of access to content from across the cosmos and without any geolocation restrictions. Of course, NordVPN's protection covers you across all your devices and they have a 30-day money-back guarantee. So you've got absolutely nothing to lose. Are you ready for liftoff? Visit nordvpn.com/StuartGary or use the code StuartGary at the checkout. So, don't just explore safely and freely with NordVPN. And remember, this special offer is only for our SpaceTime listeners. So once again, visit nordvpn.com/StuartGary or use the code StuartGary at the checkout for our special offer. And of course, we'll include the URL details in the show notes and on our website. And now, it's back to the show.
This is SpaceTime with Stuart Gary.
Astronomers have discovered the youngest hot Jupiter ever seen. Hot Jupiters are giant gas exoplanets in tight orbits around their host stars. They're thought to have been originally formed further out in their star systems, but then migrated inwards to their current orbital positions. However, a study of a hot Jupiter known as Ci Tau b is raising more questions than answers about its origin. A report in the astrophysical journal Letters suggests that Ci Tau b has a close 9 Earth day orbit around its host star Ci Tau, which is located some 450 light-years from Earth in the constellation Taurus the Bull. The trouble is, the star is only around 2 million years old, and that's far too young to have such a mature planet orbiting so closely. For decades, most astronomers believe that giant planets, like the gas giants Jupiter and Saturn in our solar system, would have formed further out from the host stars over periods of around 10 million years or so. But the discovery of dozens of hot Jupiters out there have led to new theoretical models that might describe how such planets could form. Now, a 4-year near-infrared spectroscopic analysis of the Ci Tau system has provided some surprises. Astronomers have been studying Ci Tau b's brightness, mass, and atmospheric carbon monoxide levels to answer questions about how a planet so large could have formed around a star so young. One of the study's authors, Lisa Prado from the Lowell Observatory, says importantly they were able to undertake spectroscopic observations of the planet itself, the first time this has been done for such a close-in planet around such a young star. The most valuable way to learn how planets form is to study planets like Ci Tau b that are either still forming or have only just completed forming. Ci Tau b's age made it a perfect candidate for observation with the Emerson Grating Infrared Spectrograph. It's a unique high-resolution instrument that was used during observations of Ci Tau b from both the McDonald Observatory's 2.7-metre telescope and the Lowell Observatory's 4.3-metre telescope. Because each atomic element and molecule of a star emits light at a specific set of wavelengths, astronomers can look for specific signatures or spectral lines to see if an element is present in a distant star or planet. Spectral lines can also reveal the temperature and density of a star and how fast it's moving. Prato says the research team used the spectral lines from carbon monoxide to distinguish the light emitted by the planet from the light being emitted by the nearby star. But many of the spectral lines that are featured in the planet are also featured in the star. If both the planet and the star were stationary, then the spectral lines would blend together, making them hard to distinguish from one another, meaning scientists wouldn't be able to tell what came from the star and what came from the planet. But because the planet's orbiting the star rapidly, its lines are shifting back and forth dramatically, allowing astronomers to subtract out the star's lines and see only the lines coming from the planet. And from those, they could determine how bright the planet is relative to the star, which tells them something about how it formed. That's because the brightness of a star or planet depends both upon its size and its temperature. Direct observational evidence of the mass and brightness of Ci Tau b is especially useful because we also know it orbits a very young star. Most of the hot Jupiters found so far were found orbiting middle-aged stars. But Ci Tau's age provides a tight constraint for testing models by providing a unique empirical yardstick by which to measure competing theories. Can they produce a planet this bright and massive in so little time? The author's analysis of the spectral lines from carbon monoxide shows that Ci Tau b has a mass of around 11.6 Jupiters and is around 134 times fainter than its parent star. At about 2 million years old, Ci Tau b is by far the youngest hot Jupiter directly detected. Prato says that provides strong evidence that it formed through a hot start process, a theoretical model that describes how gravitational instabilities could form giant planets more rapidly than traditional accretion models.
There's no way you could possibly make up the things that we see with telescopes. They're incredible. It's better than any kind of fiction. Our sun is sort of unusual in that it's all by itself. Most stars, if you go out at night, clear night, you look at the sky, you see all those little points of light. About half of those points you see are actually systems of more than one star. 2, 3, 4, 5 stars, all gravitationally bound. My name is Lisa Prato. I'm an astronomer at Lowell Observatory, and I work on very young binary stars and planet formation in very young stellar systems.
Dr. Lisa Prato's research is aimed at solving a big question. How do planets form? The answer lies somewhere inside a star system. Dr. Prato doesn't look for any old stars. She looks for only the youngest ones.
These are things that are, compared to a human, would be minutes old. And for stars, they're 1 million years old or 2 million years old. So they're these newborn stars. These young, wild, misbehaving stars are very unstable, very variable. So it's excruciatingly difficult to look for planets in these systems.
But very young stars are the only chance for Dr. Prato to catch a glimpse of a disk of dust and gas that's left over from the star's birth. Inside this disk is where planets form. The search for young stars with planets becomes especially interesting with binaries.
You have 2 stars, and both of them they're born together, they're exposed to the same conditions, the same environment, and the 2 stars have the same temperature and the same mass. Why, in some cases, does only one star still have a disk and the other star doesn't? Does that mean the other star has already formed planets, or does that mean the other star didn't form with a disk? Or there's these great questions, and when you have 2 or more stars together, you actually have a sort of a built-in control.
Who knows what answers Dr. Prato might find now that IGRINS, the most powerful infrared spectrograph in the world, has come to DCT through collaboration with the University of Texas and KASI in Korea. Dr. Prato realizes that all future breakthroughs rely on collaboration. Most importantly, by passing the scientific method on to the next generation of astronomers.
I think the most important thing that I do is actually mentoring students and interns and postdocs. That's really key to passing along knowledge and ideas, not just the science itself, but also how to do the science, is the ethics and the things that should drive the work in astronomy, which are curiosity and determination and dedication and honesty.
That's Lisa Prato from the Lowell Observatory. And this is SpaceTime. Still to come, new insights into the atmosphere and star of an exoplanet. And later in the science report, scientists have now discovered 125 mammal species that glow in the dark. All that and more still to come on SpaceTime. Astronomers have failed to find any signs of an atmosphere around the Earth-like exoplanet TRAPPIST-1b. The findings, reported in the Astrophysical Journal Letters, are a blow for those who had speculated that this world could someday play host to a human colony. Discovered back in 2016, the TRAPPIST-1b exoplanetary system is located just 40 light-years away, making it a celestial near neighbour. It's centred around a spectral type M red dwarf star, smaller and cooler than the Sun. So far, astronomers have detected 7 tightly packed Earth-like planets orbiting around the star, 3 of which, including TRAPPIST-1b, are within the star's habitable zone, the area around a star where temperatures would allow liquid water, essential for life as we know it, to pool on a planet's surface. These features have all fueled hopes of finding potentially habitable environments for humans beyond our solar system. The new observations examine the planets TRAPPIST-1b, C, G and H, all using the James Webb Space Telescope, with TRAPPIST-1b observed during 2 transits. By analysing the central star's light after it passed through the exoplanet's atmosphere during a transit, astronomers can obtain spectroscopic data on the chemical composition of the planet's atmosphere, providing unique fingerprints of the molecules and atoms found within that atmosphere. While all 7 of TRAPPIST-1's planets have been tantalising candidates in the search for Earth-sized planets with an atmosphere, TRAPPIST-1b's proximity to its host star means it finds itself in harsher conditions than its siblings. It receives 4 times more radiation than the Earth does from the Sun, and it has surface temperatures ranging from 120 to 220 degrees Celsius. Astronomers say they could also confidently rule out the existence of a cloud-free, hydrogen-rich atmosphere. In other words, there appears to be no clear extended atmosphere around TRAPPIST-1b at all. However, the data could not confidently exclude a thinner atmosphere, such as those composed of pure water, carbon dioxide, or methane, nor an atmosphere similar to that of Saturn's moon Titan, the only moon in the solar system with its own atmosphere, and one which many scientists believe was very similar to the primordial Earth. However, if TRAPPIST-1b were to have an atmosphere, it would have been the easiest to detect and describe of all the targets in the system. That's because TRAPPIST-1b would be the closest planet to the star, and thus the hottest planet in the system. Its transit would have created a stronger signal. All these factors make TRAPPIST-1b a crucial yet challenging target for observation. In fact, the key finding of the study was the significant impact that stellar activity and contamination has when trying to determine the nature of an exoplanet. Now, stellar contamination refers to the influence of the star's own features, such as dark regions called spots and bright regions called faculae, on the measurements of an exoplanet's atmosphere. The team found compelling evidence that stellar contamination plays a crucial role in shaping the transmission spectra of TRAPPIST-1b and likely the other planets in the system as well. They found the central star's activity can create ghost signals, and these may fool the observer into thinking they've detected a specific molecule in an exoplanet's atmosphere. And so the results underscore the importance of considering stellar contamination when planning future observations of all exoplanetary systems. This is especially true for systems like TRAPPIST-1, since it's centered around a red dwarf star, which can be especially active with star spots and frequent flare events. This is SpaceTime.
Gear Patrol calls their new dive watch the best sub-$500 dive watch. Full stop. Men's Health rated them as the most stylish solar watch in the game. Who are we talking about? It's Movement. They're leveling up your gift giving with the sleekest watches you can buy and the biggest deals of the season. From their innovative ceramic materials to sexy automatic divers, from ultra-thin dress watches to solar-powered statement pieces, and everything in between, Movement is making sure you're the good gifter this year, for your family, your friends, or for yourself. And now you can take advantage of 30 to 50% off Movement's California clean watches, jewelry, and accessories to get them a gift they'll never forget. With fast, free shipping and returns and amazing bang for your buck, Movement makes for a relaxed shopping experience. And with one-size-fits-all watches, it's an easy, elegant gifting experience too. Shop 30 to 50% off now at MVMT.com. That's MVMT.com.
We can stop HIV, Iowa.
One key step, getting tested for HIV.
An estimated 14% of people in Iowa living with HIV don't know their status. The CDC recommends everyone get tested for HIV at least once in their lifetime, or more often when needed.
So testing is important.
Yes! Testing is the only way to know your status. It's the first step in getting additional HIV prevention services or HIV care.
Find out more at stophiviowa.org.
And time now for another brief look at some of the other stories making news in science this week with a science report. A new study has found that koala populations across Australia have been decimated by bushfires in recent years, and researchers are forecasting that these wildfires will continue to threaten them and their habitats even more in coming decades. By generating fire susceptibility maps from the present through to the year 2070, scientists were able to identify the threat that wildfires pose to koalas both now and under future climate change scenarios, and they found alarming outcomes. The findings, reported in the journal Environmental Technology and Innovation, show that almost half of Australia's koala habitats will be under high bushfire threat by the year 2070. There are fresh warnings today that at least 40% of amphibian species around the world are currently under threat. The findings, reported in the journal Nature, are based on an international assessment of 8,000 species. The assessment was done last year to update a previous analysis of amphibians in 2004, which showed that they were the most threatened type of animal with a backbone in the world. Researchers say that the threats posed to amphibians are ongoing. However, while the vast majority of threats back in 2004 were related to disease and habitat loss, ongoing and predicted climate change impacts are now responsible for 39% of the deterioration in the status of the animals. Scientists have now discovered around 125 mammal species that glow under ultraviolet light. The findings, reported in the journal The Royal Society Open Science, covers all 27 orders of mammals, suggesting that it's actually quite widespread amongst mammal species. Researchers say it's still unclear exactly why animals have this fluorescence, but it's likely to be used to make their skin and fur appear brighter and enhance visual signaling, especially for nocturnal species. Okay, time now for the silliest story of the week. And a Wyoming couple enjoying a ride on the popular Durango and Silverton narrow gauge steam railroad, which snakes its way through southwestern Colorado, have videoed what appears to be the ever-elusive Sasquatch. Tim Mendham from Australian Skeptics says it's one of the most unusual Bigfoot sightings ever seen.
I thought it was great. I like a good Sasquatch film. Everyone thinks Sasquatch is up in the northwest of America, where it's all foresty and stuff like that, but there's supposed sightings, have to say supposed sightings, in almost every state, all the way down to Florida, of these sort of humanoid animals on the prowl. And this one was supposedly taken from a steam train, small gauge tourist train running between a couple of towns in Colorado. The story goes that someone was supposed to be filming on behalf of someone else to try and spot elks and therefore they were filming out the window. They were towards the back of the train, filming out the window, and they saw something moving. Now, if you look at the original video, this thing moving was a long way away. But they saw it moving, apparently, and then most of the videos you see online are enlarged, so it makes it look a lot clearer. So this creature they saw, which is humanoid, very person thing, he's walking along through some low brush, low scrub, and then sits down and then lies back. But what's happening is that some have suggested it's lying down, hiding in response to the train.
But it would have heard the train minutes before, hours.
It's a steam train going clunk, 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 clunk. And so that doesn't hold water to me, right? But then what it is seemed to be doing is lying down when it sees someone filming it, which would be an interesting prospect for a Sasquatch to know when someone is filming it. And one of the strange things about this video is that it pans off to the right and doesn't film the creature anymore. Creature's still, as far as I can tell, sitting on the ground, but then because the train is moving along, you'd think you'd be turning around and filming this thing for as long as you could. It doesn't come along very often that you see Bigfoot, but no, the camera just pans on as if it's just going along.
I got to tell you, it looked more like a Wookiee than a Sasquatch to me. It was long and thin like a Wookiee. Sasquatches are supposed to be tall and broad.
Looks like a Wookiee costume. You can buy them for about $300 in the US, apparently. I looked them up. And the people themselves don't seem really ridiculously excited about this thing. I don't know how often they spot a Sasquatch. They say, there's the elusive creature, there it is, blah, blah, blah. And you think, I'd be running around screaming or something. Look at that, look at that, look at that. And sort of, in a rather high-pitched voice and saying how exciting it was. They don't seem hugely excited.
Normally when you watch episodes of Finding Bigfoot, they're doing the finding, or the searching at least, because they don't actually find anything. They're doing the searching at night. So one assumes Bigfoot would be nocturnal. Yet this is broad daylight.
Yeah, the famous Patterson film that was in the late 60s was daylight as well.
The people who made the film later admitted that it was a hoax.
Certainly the guy who got dressed up said it was him all along. And, if that's daylight, most of the things at night. See, I don't know why ghosts don't come out at night. What's wrong with the ghosts during the daytime? What's their problem? Because they're going to be seen? There is actually a company in the town they were heading towards which promotes Sasquatch tours. Now, they're actually very subtle about this. They're actually pretty cool, it seems to be. They're mainly just promoting four-wheel drive camping trips out of the wild. So it's an interesting coincidence.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from SpaceTimeWithStuartGarry.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies. Or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to SpaceTimeWithStuartGarry.com for full details. And if you want more space time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgarry.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGarry on Twitter, @SpaceTimeWithStuartGarry on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.
The holidays start here at Baker's with a variety of options to celebrate traditions old and new. Whether you're making a traditional roasted turkey or spicy turkey tacos, your go-to shrimp cocktail, or your first Cajun risotto, Baker's has all the freshest ingredients to embrace your traditions. Baker's, fresh for everyone.
We've locked in low prices to help you save big store-wide. Look for the locked-in low prices tags and enjoy extra savings throughout the store. Baker's, fresh for everyone.